All right. So one of the themes I want to mention here about drones is automation. ARC stands for Automation Research Company, and so we cover the automation space. And it took me a second to step back and think about the levels of automation of drone. There is a tremendous amount of automation that goes into the drones that all got put together into pieces. And although we're primarily talking about aerial drones, you should also consider that really drones are a subset of robots. So you could have undersea drones, autonomous robots are a form of a drone as well. So we're probably mostly talking about drones that we would see for in the air for inspection and delivery. So in terms of the automation, just imagine how much stuff has gotten automated. If a drone has a gasoline engine, that gasoline engine has fuel injection and all kinds of complicated controls to run the engine. If it has electric motors, there are servos in those motors. If it has batteries, there's battery management system and thermal management, all these other aspects of automating the batteries, right? Then, of course, a major innovation came when you had quadcopters and things, and you could coordinate 4 separate propellers to hover in space, with gyroscopes now and gyroscopes and compasses and GPS. When you let go of the controls, it just hovers in space. You can set those controls up for first-person view. You can set them up to operate in the form of a helicopter. So the sophistication of the actual joysticks and controls to operate drones is another aspect of stability and also in navigation. Drones increasingly are able to navigate autonomously in a flight path. In the agricultural field, they'll go up and down the field row by row, take photographs of every single tree or plant. They will be very sophisticated in terms of how they could operate and navigate. Obviously, you've seen drone displays at sporting events and things of this sort that are operating as a swarm and interacting together. Then obviously the whole communications systems that you have with drones, you have perhaps radio frequency communication from your control system. It could have Wi-Fi as well. There's plenty of other wireless communication technologies going on in drones. The whole planning of the mission logistics, could be quite complex. You have to, in some case, register with the airports, nearby airports, or get permission. I think it's called the LANC, LAANC permissions. But just the planning and logistics of what you're going to do in any particular mission, who's going to fly, how it's going to gather, do you need a drone operator and a robot or camera operator separately? There's a whole collection of data, is also important. When do you take photographs? Can you be, we'll have to ask Jason maybe later, can you go down a power line and be monitoring a power line and suddenly see what might be a problem and then interrupt that flight plan to take better photographs around a broken insulator on a line or something? How sophisticated, the online visual analytics and machine learning algorithms might be. And then there's another whole aspect of automation, which is the data management part, right? Once you've started collecting data from your drone, sure, you got thousands and thousands of photographs. Some of these are, I don't know exactly the size of them, but when you get a 30 megapixel camera and you're starting to take 4K video at 60 frames a second or something, you collect a great deal of data. When you combine that data with satellite data, with manual gathered data, with weather data that appeared at that time, all time stamped and synchronized, you start to get petabytes worth of data collection and the entire management of that. So if you have so much data, are you going to sit down at a computer and go frame by frame and say, I don't see anything wrong here. I don't see anything wrong in the next frame. I only have 400,051 frames to go. So you really need to be able to look through frames of data capture with the ability to recognize problems. So there's a lot of technology and automation that go on in there. So I think what you get appreciation for is there's a lot of automation that goes into drones, right? And a lot of things depended on other things in order to get to where we are. So let's give a kind of a brief summary of where drone inspection and delivery are. I have yet to put the Amazon landing pad in my backyard. For $150, you can get a license to operate a drone and participate in commercial markets. But there is one lot of rules and regulations that you need to be able to follow. So we also see that drone waivers from the FAA tend to be given in very confined situations on rural locations where there's low risk, or at least the benefit of the drone application compared to the risk is a high benefit. We've seen some FAA, I think, as you've seen in the news, maybe has approved some kind of medical transport, to save lives, urgent, delivering an organ from a donor to a hospital for somebody waiting for surgery, things like this. We've got a few approvals here and there. In some of the rural areas, you'll see drone approvals as well. But still, to fly drones over people, to fly them in anywhere near airplanes, we still have those same limitations. You also would see that from a worldwide perspective, we see, in fact, I was going to have another speaker here, but unfortunately she is at another drone conference in Rwanda today, all right? And the reason is that Rwanda has established a very established drone program with their zipline program, with a fixed wing aircraft that can be delivering packages, including medical supplies, for example, over longer distances. You call up on the phone, they got a drone, they shoot it out. It just drops a line. I think I might have a picture of one of those zipline planes in here. And so you'll see that in rural areas. Europe has a fairly organized drone program, but a number of the African and South American programs are a little bit different. But even as those drone programs start to mature, I've heard Lux mention that he'll be working with Rwanda to help establish the equivalent of an FAA there, because problems do develop. Interference with aircraft is still an issue. So so obviously we still don't have all of the technology in place to be able to operate drones in synchronization with commercial aircraft. There's obviously the issue of pushback from issues of noise, tranquilities. You can't just fly your drone around the Empire State Building and start taking photographs, or Mount Rushmore. You're not allowed to fly drones in national parks and most state parks either. So there's a privacy issue, and there's also some safety issues flying over people. What happens when drones crash into people? Could you make a teeny itsy bitsy lightweight drone with a fabulous camera in such a way that even if the drone hit you, it didn't hurt you? I think Lux has some data on testing with drone collisions and people. Obviously, we are very much familiar with drones and weaponization. So obviously that's definitely a threat. You could imagine that during the Super Bowl, there was considerable precautions and rules and regulations about how far drones had to be and how to detect drones and how to intercept drones. So there was a lot of money spent behind the scenes, just as Kansas City was finally coming back in the fourth quarter, right? So it is about safety. Taking that to another level is when you start using drones for delivering people, all right? Obviously, those drones, have to achieve a certain certification and reliability. There's a huge amount of money being spent in that regard. Boeing and Airbus and a number of other companies are funded that. There's a lot of private funding. Uber has imagined their Uber X program, and Uber in they can just imagine that in Los Angeles, that they could just be set up a 4 or 5 drone landing pad on top of buildings in parking lots. Their economics show that for about $40 you can go 40 miles. And there's a lot of people that would pay $40 to go 40 miles in downtown LA to get rid of the traffic. There's a little bit more room in 3-dimensional space compared to these 2-dimensional roads. Obviously, there's a whole system of legal risk. Who's responsible for what? All right. If you have an unmanned drone and it crashes into something, you're going to put that programmer in jail, or are you going to put the drone company in jail? Those are complicated issues. I just thought for interest here, this is the FAA visualization map. We technically are right there at the intersection of Route 4 in Orlando with that, I can't remember the side, the horizontal line. Technically, we are allowed to fly drones in this area, but all the other places in circles, you're not allowed to fly a drone. So just to kind of review Part 107 rules, this is there's an awful lot of businesses that are operating in this Part 107. All it requires is a remote pilot certificate. You have to be 16 years of age. It costs about $150, all right? But you have to pass a test. All drones will be required to be registered, including toy drones. So basically, drones are going to have license plates, all right, so that they can be identified. You're limited to 400 feet max, visual line of sight, unaided. That's not with binoculars. You need to operate in daylight hours. You have to keep your drones down to under 100 miles per hour. Although I think for some of the drone racing programs, I think they're going even faster than that inside of buildings. If you've ever seen any of these drone races inside, they basically go inside a stadium, and man, they are really fast. Not over people, no operation in restricted areas, and if you are going to operate in certain areas, you're required to get a space authorization prior to takeoff. So it's interesting that in terms of the automation of flights and missions and data, that we recall not long ago that the Yemen's rebels claimed a coordinated attack on a Saudi refinery location, Abqaiq, and they launched 18 drones and 7 cruise missiles. Each of those was guided by a GPS. There's no pilots, no swarms. In some ways, it was a very simple level of automation. You launch these things, they go to GPS coordinates, they arrive at their target. Autonomous weapons are advancing in the case of tanks and ships and planes. There's a lot of different programs going on. The United States is certainly not the only one that is building new autonomous weapon systems or autonomous drones. ARC generally does not get involved in the military applications. We're pretty much exclusively industrial and commercial, but it's hard not to keep your eyes open because the military has been such an advancement in this technology. One of the concerns, though, is that in many cases, for example, fighter pilots' career path, looks I don't know what would you call it, lux, with autonomous fighter jets and things that don't need to stay down to the G limitations that us humans have. They can fly very, very fast, and also in terms of decision making and autonomy, they can respond, through this massive quantities of data faster. And so the kind of interesting problem you get into is if we're going to take a fighter jet, an autonomous fighter jet in the U.S. and have a dogfight with an autonomous fighter jet in Russia, we don't know what they're going to do, and they don't know what we're going to do. All right. So the point is that whatever they're going to do, we better do faster. And they're probably going to say, well, whatever that other guy does, I'm going to do faster. All right. So basically, what it means is that algorithms need to be pre-built ahead of time so that you're the fastest and you win, all right? But there is some risk that gets kind of a little bit out of control, and that you may have misinterpreted the intentions of your opponent, all right? And I know that I think there's one here, Lieutenant Colonel Stanislav Petrov, all right, in '83 was the guy that kind of saved the world. Their radar in the Russian systems picked up missile strike, missile launch, and he was the one that was supposed to launch a retaliatory strike against the U.S., but it turned out it was sun reflecting off of satellites that was misinterpreted as that. And that human in the loop did not press that button. Now, the thing is, you're a programmer. At what point you decide as a programmer you are going to press that button? And so in any event, so autonomy has some interesting problems, all right? I also like to mention this 2011 Amazon book pricing algorithm. There was a book called The Making of a Fly, all right? It was kind of a technical book about insects, and the cost was $50 plus $3.99 shipping. But one of the publishers had an algorithm that said, oh, that's going to be 1.27 times my competition because we are the premier supplier. The other publisher says, well, we want to be the low-cost supplier, and he wanted to set his pricing at 0.9 times the other price. So every day, at the end of the day, they looked at the price of that book, and one guy multiplied it by 1.27. The other guy said, well, I'm going to be 0.29. But on average, that was an increasing price. So every day, the price of that book started launching up. And some guy actually went to buy that book, and he noticed day by day, the price kept going up. And when he last checked, it got to almost $24,000 plus $3.99 shipping. All right? And so you can see the problem of instability in algorithms. We certainly know in the automation space that we have here at ARC that, if you have a loop gain greater than 1, the controllers will start oscillating and go unstable. We know about these kinds of things, but, we certainly see that in many of the other expert systems and algorithms. This is a picture of the Abqaiq Saudi refinery. Obviously, we're very concerned about weaponization even here at home. You just pick your targets, plug them into there, and turn them on. Almost the drones you can buy from DJI today, the simple consumer drones, can almost do the same thing, except they just don't have the range. So in the U.S., we have a UTM, the traffic, unmanned aircraft traffic management system being coordinated by NASA. In Europe, there's a U-Space system of aviation agency, all into testing. You can get a few FAA permits. You see these coming out already. Probably Lux would be able to mention that a little bit more. Obviously, from a growth rate, unmanned aerial systems are very popular. You see drone racing is a big deal. So it's growing 6 to 7% per year. FAA certified pilots grew 50% over the previous year to 115,000 licenses. There is a proposed rulemaking for drone identification. This is the license plate idea. And, obviously we see a number of other advances in sensors and cameras and LIDAR, which give them more capability to gather data and improve the ability to inspect things. Farmers tend to use ultraviolet cameras. Inspection of a solar panel can very quickly determine solar panels that are not working from an infrared camera. One of the other things which I guess I would mention is that, well, it's a very competitive situation. A lot of companies are folding. 3D robotic, GoPro crashed. Airwave. So this is a very dynamic and competitive market. DJI, all right, the Chinese manufacturer of small recreational and commercial drones, it still is dominated with 70% of the market, and they're very hard to upset. They're a very powerful force. I would mention also, I don't know that I had it in here, but I think as of January 1st, all commercial aircraft are required to have ADS-B out. All right, that means all of the commercial aircraft are broadcasting a signal that is determining their position, location, and velocity, and drones are able to pick up this signal and be able to identify from your drone control panel that you are flying nearby an airplane. Ironically, it's not yet possible for the drones to broadcast the same signal to the aircraft. So if you're in an aircraft, you You don't get any information about where the drones are. Only the drones got information of where the aircraft was. Obviously, for somebody that with terrorist intents, that's not an impediment, right? Yet, that basically the reason for that is that to broadcast that out from a drone would overwhelm. There's so many drones, it would overwhelm the traffic management system today. So the communication bandwidth just is not there yet. All right, and maybe someday that will happen. In terms of the drone market, construction, agriculture are some of the top activities currently in the drone market. So really, those are really both inspection type of algorithms. I mean, it's inspection types of applications. There's increasing interest in fire and police, insurance. You could imagine that after a hurricane or something, the insurance industry wants to be able to get an assessment of how much damage was done and be able to get quickly estimates of damage. You can sell your house with a 3D dimensional map of walking in the house, but you can also take drone footage of the outside of your property and put that on your listing, so you can demonstrate your house with more effective things. In terms of drone delivery, outside of the U.S., we certainly see that, but in the U.S., you mostly need the FAA permits through Section 333, and it takes some effort in order to get such permits. And you can still fly. Really, Part 107 is not possible to use, I think, for most drone deliveries unless it's on your own property, all right? But to carry packages for other people is monitored by Part 135. You could see this patent from Amazon on the left-hand side. They could imagine this beehive for drones. So that beehive gets filled up with packages from trucks and rail systems, and drones are then delivering oftentimes in the last mile, right? And there's my landing pad that I can put. I got the spot in my backyard just to put that landing pad so that's where I will pick up my packages when they start to come. But so far, Amazon can't do this in mass. But obviously, lots of money and lots of effort are being presented here. This is actually the zipline, the Rwanda zipline plane. A very simple drone, just catch and release, drops a package with a little parachute, bang, delivered. All right, and they've been in business for, 5 years now, maybe. I'm not quite sure. And so obviously there's lots of issues still with regulation. Obviously those regulations are risk-based. There's still, weight issues and limits, and the air traffic control. There's also a very significant anti-drone marketplace, all right? You better believe that there are ways of detecting whether the drones are by receiving the type of electric radio waves and signals that might be used to control the drone. Those can be viewed. There's also by the sound of drones, they can detect drones. There's a number of different technologies in terms of the detecting of drones. A lot of drones have built-in geofencing so that if you tried to fly that drone into an airport, it would stop at the border. And so they actually could also, you try to fly it into a building, it recognizes the building with cameras and other sensors, and it will prevent you from crashing your drone. So a lot of technologies. Obviously, you could jam the signal to drones. You could fight a drone with a drone. Your drone just has to be faster. And then there's nets and projectiles and lasers, and they've even used eagles to attack drones. In terms of drone automation, in terms of moving people, on the upper right here is a company called Lilium that was started to make what amounted to as a recreational drone, but ultimately decided that the marketplace for this is a 5-passenger people delivering drone, and they've worked with some private funding in the European Space Agency to develop this drone, and that drone is flyable. They're hoping to bring that to market here within a few years. The bottom right, I think, was an Uber-funded program through Boeing, all right? And Boeing in the fall of last year, I think, purchased a company called Aurora Flight Sciences, which was very much into building a lot of the DARPA based airplanes, a very expert company at designing aircraft from scratch, and built built all kinds of different aircraft. But anyway, these are the two of the possibilities that may start to show up. You can see the Lilium has a 300-kilometer range. I think it can go 300 kilometers, and it can make that range in an hour almost. So it's pretty fast. So here's another interesting drone. This one does not possible in the bottom left. This is the Mars. This is the Mars drone projected to land on the surface of Mars and fly in the very thin atmosphere of Mars. All right? So obviously, first-person view is a little bit of a problem considering the signal delay is quite long. So everything has to be completely autonomous. It's not clear whether this will actually fly there, but you can see it's a solar powered. There's a little solar panel on it, and it will be able to pick up and take instruments and cover a wider view. It's the first kind of experiment in a low atmosphere environment. We still haven't quite got to the Jetsons, that I think we're not quite sure what it was powered by, but those, I wish I had that little audio clip, the little bing, 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 puttering along, right? And but I think it went 7,000 miles an hour. So we got a ways to go. So in any event, that's ends my presentation. And I think we'll go with Steve is up next. Is that how it's organized? Right. Thank you.